Okay, let's take a look at this. And let's see, I might be able to write right on this page. So let me go to my tablet, switch to desktop mode. There we go. Determine which numbers in the set are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Natural numbers. Now, natural numbers, remember, is 1, 2, 3, on forever. It doesn't start with 0 and there's no decimals. 12 would be a natural number, so that's why that's marked. Negative, you can't have. Negative, you can't have. Now, square root of 9, you might say, well, that's not one of these, but square root of 9 is equal to 3, which is a natural number, so that's why that one's checked. Can't have decimals, so that's not one. Can't have fractions. 17 would be a 1, so that's why that one's marked. Can't have decimals or negatives. And 6 is a natural number, so that's why that one's marked. Now, whole numbers. Whole numbers go from 0, 1, 2, on up, forever. So 12 would be a whole number. Can't have negatives, so those are both gone. Square root of 9 again is 3. That's why that one's marked. Can't have decimals, can't have fractions. 17 would be a whole number. Negative 3.6 can't have decimals. 6 would be a whole number. Now, integers. Got negative 2, negative 1. Forgive this writing. I can't write on here very well. 2. Then goes forever this way and goes forever this way. So basically, you can have negatives. You can have 0. You can have positive. You can't have decimals. You can't have fractions. So 12 would be an integer. So that's why it's checked. Here's a negative 19. You can have that. There's no decimals. So that's checked. Here's a fraction. Only if that fraction simplified to a nice integer would we take it. For example, if this was negative 18 over 6, 18 over 6 would be 3. I'd have negative 3, which would be an integer. Square root of 9 is 3. That's why that's an integer. No decimals. That does not simplify nicely. 17 would be an integer. No decimals. 6 is an integer. Now, a rational number. What a rational number means, it means you can write it in fraction form. Even more than that, A and B are going to be integers. 12. You might say, well, that's not a rational number. Well, we can put 12 over 1. So we can always create a fraction by putting over 1. And this is an integer and this is an integer. So that's why this one's rational. Negative 19. Same idea. I can put negative 19 over 1. That's why that's a rational number. Now, negative 17 over 6. These are already integers, so that's good. Square root of 9. Well, square root of 9 is 3, and you can rewrite 3 as 3 over 1. So that one's good. 3.35. You'll maybe look at that, it's like, well, that doesn't seem right. Well, this ends in the hundreds place, so to rewrite this as a fraction, be 335 over 100. Top is an integer, bottom's an integer. So 3.35 is. Now, pi is irrational, which you see got marked down here for this one. 17, I can write as 17 over 1. Negative 3.6. This ends in the tens place. So negative 3.6, I can rewrite as negative 36 over 10, since it ends in the tens place. And this is an integer, and this is an integer. And then 6, I can rewrite as 6 over 1. So that's why that's marked. And that would be that problem.